So this is my presentation on the history of the structure of the atom. So I've had a few goes at this now because of interruptions and other things. So I made this PowerPoint all about it. You'll be glad to know. So these are some images of what I found on the internet. The same image, in fact, of just showing the theories of how it was working, of how they thought it worked at the time. So yeah, the first one is ancient Greek. So they had a philosopher called Democritus in the 4th or 5th century BC, and he knew that if you had a rock and you split it into, it would have similar properties to the other half. So his theory was that you would cut it into smaller pieces and it would at some point become indivisible, and he named these indivisible particles atomos because that's the Greek word for indivisible. So he also believed in fact that these atoms were different depending on what they came from. So a piece of copper would be different from a piece of an atom from a piece of copper would be different from an atom from a piece of iron. And he also believed that they could collide with each other and create other particles, other compounds and such like, and they could either stick together, chemical. He didn't think it. He wouldn't have known it was, but or it could rebound just separating off, and it was like turned down by another major philosopher at the time, and it was ignored for a few thousand years. Well, not that many, but 1 or 2. So next one is early 1800s. I think that's right. I don't know. So in 1803, John Dalton developed an atomic theory about it. So he had 5 basic rules. All matter consists of tiny particles called atoms, which were seen as tiny solid little spheres in various stages of motion, and so they were moving around the whole time. So a solid, very very slow movement, and a gas, fast movement. And he thought that atoms were indestructible and unchangeable, so I suppose you couldn't turn lead into gold. Elements are characterized by the weight of their atoms, so we kind of know that now. I don't know if isotopes are an exception, but yeah, hydrogen obviously weighs more than, less than helium, and it will form in different ratios. Chemical elements combine in small whole ratios to make stuff like 1 oxygen atom with 1 oxygen atom equals O2, which is what we breathe. And when elements combine in more than 1 whole number ratio, so carbon dioxide and carbon monoxide, so different numbers of oxygen atoms, meaning that it forms different compounds. So a bit after that, J.J. Thomson proposed the plum pudding model, as it's called today, because it supposedly looked like a plum pudding. They had an area of positive charge with electrons scattered around, which supposedly made it look like a plum pudding. It was because they knew atoms had an overall neutral charge. He found evidence of bodies much smaller than atoms, electrons, which had a big charge-to-mass ratio. So I think if I remember right, they electrons have over about just a bit under 2,000 times smaller than proton, and they had the same charge as a proton, so that is correct. Which, but he called them corpuscles, but we called them electrons. So yeah, I don't know how to pronounce that. Don't quote me. So Ernest Rutherford discovered the alpha and beta rays, and stated like the original laws for radioactive decay. So I suppose random and spontaneous, probably a few others that I don't know about, and probably a lot of others, from which he discovered that alpha are helium nuclei, as we should know from GCSE. So maybe his most important discovery was the position of subatomic particles. So he discovered that they had a central positively charged region and the electrons. So didn't know where they sat or anything, just that in the middle was a proton and a neutron and around the else. But he didn't know about neutrons at the time, he just suggested the existence of them. So Niels Bohr discovered that electrons move around the nucleus in certain orbits, so in certain shells. His theory could explain why atoms emitted light in certain wavelengths. And the next one is James Chadwick. So he actually discovered the neutron, which Rutherford had already suggested existed. He followed on from some work from two scientists in Paris who interpreted their readings wrong. So potentially he might not have really been known really, because he got it from someone else. And he found that by bombarding wax with radiation, protons were released in a way that it suggested that they were hit by neutral particles, so not atoms, smaller neutrons. So yeah, he discovered the neutron. I think he later went on to work in the nuclear field, kind of developing the first nuclear bomb kind of thing. Don't quote me on that either. So here's today's kind of idea. This is a C12 atom, so the most common isotope of carbon. So 6 protons, 6 neutrons, 6 electrons. All have the center of the nucleus having a mass of 1 each part, so each neutron, each proton, and the electrons having an almost non-existent presence apart from the charge of -1, the neutrons being neutral and the protons being +1. So thanks for watching. Oh, I forgot a bit. And don't forget that they have shells, so 2 on the first layer, 8 on the next, but obviously only 4 on this because 6 electrons. So yeah, thanks for watching, and I hope this was good enough information for you. Thanks. Bye.